Everyone, so in this video we are going to discuss about the past paper questions from the topic dynamics, and we are going to solve past papers from the paper 2024. Okay, the first question, we have a car of mass 1200 kg and it has a momentum of this much. You have the mass, you have the momentum, you have to find the kinetic energy of the car. Okay, so let's figure it out how we can solve it. Kinetic energy, we know it is equals to half mass into velocity square, right? But we don't have the velocity, so we can find the velocity from the momentum. We know momentum is equals to mass into velocity, so velocity is equals to momentum over mass. Okay, you can find the value from here of the velocity. You can put this thing into the kinetic energy formula. It will give you 1 by 2 m, and at the place of velocity you can put p over m and there is a square on it. It will give you m momentum square divided by 2m square. That will leads to p square over 2m. Okay, that is kinetic energy. There is also a very important relation to keep in mind, that momentum and kinetic energy can be related by this relation. Okay, so you just have to put the values. The values are 18,000 square divided by 2 into 1200. So you will get 13530. Okay, so it's option C. In the next question, a toy parachute is dropped from a bridge and falls vertically through the air. The graph shows the distance traveled by the parachute against time. Which region of the graph shows when the parachute is at terminal velocity? So it's a distance time graph. So in this case, slope is representing the velocity. And we know that straight line shows the constant velocity. So terminal velocity means the constant velocity, constant maximum velocity. So this is represented by this line. Okay, so it's option B. That is correct. In question 3, a lift elevator consists of passenger car supported by a cable that run over a light frictionless pulley to counterbalance. The counterbalance falls as the passenger car rises, and what you have as some masses are shown on the table. But you have to find what is the magnitude of the acceleration of the car when carrying just one passenger when pulley is free to rotate. Okay, so you have to find the acceleration. So to find the acceleration, what we have to use Newton second law. What the Newton second law is, F is equals to ma. That is, a resultant force is equals to mass time acceleration. So acceleration is equals to resultant force divided by the mass. Okay, so if you see this scenario, this passenger car and the passenger, they are together, they have the combined mass, and this counter, and they are attached with each other through the pulley. So they are acting as a whole system. Okay, so as a one system, so they will be accelerated together. So this mass that I have taken here will be a combined mass. This m will be equals to mass of passenger car plus mass of passenger plus mass of counterbalance. Okay, so this can be written as a is equals to f divided by 5. Car has a mass of 520, person has a mass of 80, and the counterbalance has a mass of 640. Okay, so what we need to calculate now is this resultant force, what it is. So now look at the scenario. What we have here, there is, this thing is moving downward like this. This is a direction of motion, right? That is given. It's moving like this. So why it's moving like this? Because of a force downward. This force is basically its weight. its weight is equals to mg. The counterbalance has a mass of 640 and g is 9.81. So this much force is applied here downwards, and upward force is the tension, right? And from where this tension is coming? This tension is coming from here because of the weight of these. What is this force? This is the weight of passenger plus weight of the car. So it will be, passenger weight will be 80 into 9.81 plus the car mass will be, the passenger car mass will be 520, and it's, to calculate the weight you have to multiply it with 9.81. Okay, so this is the total force that is acting down here, and this is the force acting down here, and that force is equals to the tension that is causing the tension. So this thing is equals to the force of tension. Okay, so to find the resultant force here, what you can do, the F will be basically equals to weight minus tension. Okay, we are considering this portion here. So this will be, weight is 640 minus 9.81, sorry, multiply by 9.81 minus 80 into 9.81 plus 520 into 9.81. Okay, so that will give you 392.4. Okay, so substituting this value of f here, you will get a is equals to 392.4 divided by this whole mass. That thing will be given you 0.316. That is nearly 0.32. Okay, so the option is B. B is the right option. Okay. In the next question, a stationary ball of mass m is hit by the bat. The ball leaves the bat with the velocity v, and the bat is contact with the ball for the time this. Average force you have to tell. We know that average force is change of momentum unit time. Okay, so change in momentum is m into v delta t. It can be written like this. It's option B. In question 5, a disk of mass m is moving across a horizontal frictionless surface. It collides with a stationary disk of mass 4m. Then they will move like this after collision. What you have to find u. Okay, so this question is from the law of conservation of momentum, and this motion is a two-dimensional motion, right? So you have to solve this into the 2D. So what we have, if you see initially, the momentum is only in the x direction on the x-axis. If you consider its y-axis, that is 0, right? Nothing is in the y-axis. So what we have to do, initial, and if you see here, this thing is moving like this in that direction. So we can say total momentum before cooling in, we're talking about x components, okay, must be equals to total momentum after. Okay, so before cooling in, we have this capital M mass, the velocity is u, plus second was 4m, its velocity was 0. That is the before cooling in, right? After cooling in, if you have to find the component of it, this will be the component of, this will be mass into the velocity. Velocity is 4 and it will be cos 45. It will taken as cos because this component is attached with the theta. And if you have to calculate the, this will be the component of this mass. Okay, So mass is 4m into velocity is v, it will be the cos 45. So so they both are in the same direction, so they will be added up. So it will be 4m cos 45 plus 4mv cos of 45. Okay, so this equation you have for x. If you notice, in all of these the m is common, so this m can be taken as the common and it will be cancelled out. Simply this will be u is equals to 4 cos 45 plus 4v cos of 45. So here we have another challenge. We don't know the v, this velocity. So what we can do, we can make another equation. So let's solve it for the y components. Same, total initial momentum must be equals to total final momentum, right? So if you see initially there is no momentum in the y-axis, so initial is zero, right? And if you see the final, this will be the y component of the momentum, and for this it will be like this. So if you take upward positive, downward will be negative, and this will be mass into the velocity sine 45, and this will be the mass into the velocity sine 45, but one will be the positive, the other will be the negative. So it will be 4m sine 45 minus 4mv sine 45. Okay, so you can take this thing on the other side, it will give you 4mv sine 45 is equals to 4m sine 45. If you look at this thing, this 4 will be cancelled, this m will be cancelled, this sine 45 will be cancelled. So you're only left with the v, and on the right side will be the 1. So v is 1 meter per second. Now I can use this thing here. You can put this v here, and you will get, solving this again, u is equals to 4 cos 45 plus v will be the 1. So it will be the 4 cos 45. Solving this will give you 5.65, that is 5.7 meter per second. Okay, it's option D. Okay, and the next question, an object is dropped from the rest on the earth from a height of this, so s is equals to h. A same object is dropped from the rest, okay, both are starting from the rest, on the moon twice the height, so there s is equals to 2h. The acceleration of the free fall on the moon is 16th% of the value on the earth, so its acceleration a on the moon will be 16% of acceleration on the earth, that is g. Assume that there is no air resistance. You have to find these ratios. Okay, so the ratio of the velocity on the earth over ratio of the velocity on the moon. So what you have, let's solve it separately for the earth, and here we can solve it for the moon. For the earth, what you have, initial velocity is 0, height is equals to h, or it's given, it's 2 meter, right? Okay, and what we know the acceleration is equals to g, and you have to find the final velocity. Okay, for the moon we have more or less same data. U is equals to 0, s is equals to, the height is twice, right? So it will be 2 times of 2.0, it will be the 4 meters. Acceleration is 16th%. So 16th% means 16 multiplied by 9.81 divided by the 100. Okay, this will be the acceleration. Okay, so, and you have to find the final velocity. Okay, this is for the earth, this is for the moon. Okay, then we can find the ratios. So if you recall the equations of motion, The equation that we can use here, it is v square is equals to, let me write it down here. We know the equation of motion v square is equals to u square plus 2as. As in both the cases u is 0, so v square is equals to 2as. So v can be written as 2as under the root. Okay. So if we have to find v of earth divided by v of moon, so it will be under the root. For the earth, we have the data here, 2 into a is basically equals to g, and height is equals to 2, right? And for the moon, it is 2, acceleration is 16th percent of 9 of g, right? So it can be 16 multiplied by g, you can say, divided by the 100, and then the s is basically 2 times of the height on the earth, so it is 4. So if you look at this thing closely, what you can do, we can cancel these two, this g will be cancelled, and this ones are, and this will be the 2. Okay, so this thing will give you 1 over under the root 16 divided by 100 is 0.16 multiplied by the 2. So if you solve this thing, it will give you 1.769, that is 1.8. Okay, so you have the option A. The next question, a moving object strike a stationary object. Okay, the object is, the collision is inelastic. What the inelastic is, it's mean kinetic energy will be lost, it will not be conserved. Then the objects will move together. Okay, this is also an indication of an elastic collision. Assume that the two objects from an isolated system, which row shows the possible values of the total momentum and total kinetic energy before and after the collision. Okay, keep in mind momentum will always remain conserved, so they should be equal. These momentums are not equal, so this cannot be the option. Okay, so these are equal, these are equal, these are equal. Okay, so we can choose between b c d. Let's look at the kinetic energies. Kinetic energy was 30 before, and after it is 90. This is not making sense. Kinetic energy will not be gained, it will be lost. Okay, so it is not the option. It was 90 and it is 30, it is lost. It's making sense because it is inelastic collision. It is 90 and again 90, nothing is lost, so this is also not the possibility. So we have the option C. In this question, a graph shows how a quantity y varies with a quantity x for an object falling vertically at its terminal velocity towards the surface of the earth. Which quantity could x and y represent? So what we have, terminal velocity, it's mean constant velocity. Acceleration is 0, right? That is what it's mean. So if it is acceleration time graph, if y is the acceleration, this thing is showing acceleration is decreasing, right? It's going down the hill. So this cannot be the case because acceleration should be the 0. Then what they are showing, if this can be the height, this can be the time, this is showing with the passage of time the height is decreasing. Yes, it's making sense because it is falling vertically downward. Okay, but let's look at the other options. See the distance moved and the kinetic energy. Acha, kinetic energy is showing on the y. Why the kinetic energy will change? Kinetic energy is basically half mass into velocity square. Mass is not changing, velocity is not changing, so velocity, kinetic energy should also not change. So it will not be the option. It's not the correct representation. Same goes for this thing. So we are only left with the B option. In the next question, a ball of mass 2 kg travels horizontally with the speed of this. The ball collide with the wall and rebound in the opposite direction with the speed of this. The time of the collision is 150 millisecond. What is the average force? Okay, so we know that average force F is change in momentum over time, so it can be mv minus mu divided by the time. So mass we have 2, the speed was initially 4, then it strike and it will fall back. So if it's moving opposite direction, right? After it's rebounding. So if you take the final positive, the initial will be negative. One of the speed will be the velocity will be the negative. Okay, so let's take this one as positive and this one as negative. Okay, so when you put the values, mass is 2, velocity is 2.8, minus 2 into u is minus 4, divided by the time is 150, micro is milli is sorry minus 3. Okay, so that thing will give you 90.66, that is 91 newton. Okay, and the next question: two train carriage each of mass 5000 kg roll toward one another at a horizontal frictionless track. One is traveling at a speed of 2 meter per second and the other is traveling at this speed. They collide and join together. When they are joining together, it is in elastic collision. Okay. What is the kinetic energy lost during the collision? Okay, this thing is also showing it's an elastic collision. So kinetic energy lost you have to find. So to find this thing, what you need total. We know initial kinetic energy will be more, so we can write it as total kinetic energy initial minus total kinetic energy final. That will give you the kinetic energy lost. So to find the total initial kinetic energy, first carriage was moving with half mv square, mass is 5000, v is 2 square, plus we are I'm writing this for the total initial kinetic energy. Okay, 1 by 2, mass of second is also 5000, velocity is 1 square. Now the total kinetic energy final, they both will move together, so their mass will be the collective mass 1 by 2, mass will be the 5000 plus 5000 because they're moving together into the velocity square. We don't have the velocity. Okay, so now this thing is a challenge that you have to find what is the velocity. So what we know, kinetic momentum will always remain conserved, so we can find the velocity from the momentum relation. Let's try this one. We know m1 u1 plus m2 u2 will be equals to, both are moving together, it will be m1 plus m2 into v. So v is equals to m1 u1 plus m2 u2 divided by m1 plus m2. So mass is, this is 5000 into 2 plus 5000 into 1 divided by 5000 plus 5000. Okay, so this thing will give you 0.5 meter per second. Okay, okay, so this now you can put here in this equation, that is 0.5, so it can be written as 0.5 whole square, right? So calculating this whole scenario, that will give you 11250. Okay, joules. So it is option C. In the next question, the graph shows the variation of velocity with time for a stone that fall from the bridge into the lake. Okay, let's suppose this is the stone, it's moving down, that is the air, and that is the lake. Okay, so what can be deduced after the motion of the stone? Okay, so when the stone is moving from this to this will be the, it will be speed up. When it going to hit this thing, when it move down, it will slow down due to the drag, right? So If you see the diagram, the graph clearly, the velocity is increasing during this journey, and at this point, it is central. So this is the point where it hit the lake surface. Okay, so in point option A, terminal velocity was reached in the air. No, this is the journey when it was in the air, and no terminal velocity is achieved at this point. The acceleration in air was decreasing with increasing time. Yes, if you see, this is a decreasing slope, and we know that velocity time graph show you us acceleration. So this is the true option. And see, the distance traveled in water was greater than the distance traveled in air. If you see in the water, the distance traveled will be this much, and in the air it will be this much. So in the air it is clearly more as compared to the water. And the rate of change of velocity in air was constant. No, because it's not a straight line. Okay, so it's option B. Okay, in question, the graph shows the variation of the momentum with the time. What is the x resultant force on the car? Okay, so again, Newton's second law, we know F is equals to delta p over t. So you have to find rise over run, the slope of that thing. Okay, so as you see, you have to find till point in the 1 second, sorry, 10 second. 10 second will be somewhere there, so it will be on this point on the graph, but you don't know the momentum at this point, right? But there is another concept, as it is a straight line. So during this journey you can take any 2 points, right, to find the momentum, because slope will be the same. So it will be the rise over run. So its rise is, this is the rise, it is 4, let me look, write it, 4 minus 1, and there is 10 power 4 as well. Okay, divide with the run. So run is from this point, this will be the 20. This will give you 1.5 into 10 is to power 3. It is 1500. Okay, so this is the option. In the next question, two object x and y form an isolated system. X and y collide and then separate. The mass of x is greater than mass of y. Which statement about the collision is correct? The change of momentum of y is greater than change of momentum of x. The change of momentum of y will be greater than the x. How you know that? Which momentum will be the greater? Okay, so this statement is not making the sense. The force on y is greater than the force on x. No, if one object is going to hit the other object, the amount of force exerted on the y will be the same as exerted on the x. This is the action direction. Okay, this is also incorrect. The forces that x and y exert on each other act for the same length of time. Yes, because it will be the time for which the x is in contact with the y. For the same time, the y will be in contact with the x. Okay, and in the D option, the forces that x and y exert on each other are gravitational. No, it's not the gravitational force. Okay. In the next question, which row states whether two momentums and total kinetic energy are conserved in an elastic collision in which there are no external forces? Okay. For the inelastic collision, we know momentum should be conserved and this should not be the conserved. Okay, kinetic energy. Yes, option B. In the next question, a tennis ball is thrown vertically upward. The tennis ball reaches its maximum point and then fall back down to the point from which it was thrown. Okay, and there is a resistance. Okay, so you have to consider it. At which position on the path of the tennis ball is the resultant force on the tennis ball is greatest? Okay, now this concept is related with the air resistance. You have to keep in mind that resultant force will be equals to the difference of weight and air resistance. So its mean increase in air resistance will lead to decrease in resultant force. Okay, and we know air resistance is directly proportional with the speed. So when it speed up, there will be more air resistance. So the maximum, the minimum speed will be at the start. It started from the zero, right? So when it started from the zero, and at that point the air resistance will be zero. So the resultant force will be maximum, right? Okay. Then a golf club hits a golf ball. The graph shows how the force on the ball varies with the time. Which graph shows how the velocity of the ball varies? Okay. So this is showing, this portion is representing increase force, or you can say force is related with the acceleration. So I can say increasing acceleration. And this portion is showing decreasing acceleration. And in velocity time graph, we know slope is equals to acceleration. So we need increasing slope first and then decreasing slope first. So this is the increasing slope at the start and then it is the decreasing slope. Okay. So it's option B. A is not the option clearly, as this is decreasing at the first and then increasing. That is the opposite of it, what we required. Okay. And they are clearly not the options. In the next question, what is meant by the mass and the weight of an object on the earth? Okay. In option A, it's the momentum divided by its velocity. Okay. So if you look at the formula, P is equals to m by v. So mass is equals to P by v. It's making sense mathematically, but not by the definition. It is not how we define the mass. Okay. Mass is the amount of matter, and that is related with the inertia that can resist the change in the state of something, right? That can resist the acceleration. Acha, if you see this thing, what they are telling you, weight is equals to work. We know work is equals to force into d, and F can be W over d. If d is 1, you can say F is equals to W, but not in definition, right? In that case, the force is equals to the work done. Force is basically the weight of the thing, but it's not how we define the weight. How we can define the weight? Weight is the pull of the gravity or the force of gravity on the object. So it's option D that is correct. Okay. Okay. So in the next question, sphere X and sphere Y form an isolated system. The mass of Y is greater than mass of X. Okay. So mass of Y is greater than mass of X. And sphere Y is initially at rest. Sphere X collide elastically with sphere Y. The speed of sphere X before collision is u. Which statement must be correct? Okay, if this is mx, this is my, this is at rest, this is moving with a velocity u. That is the whole scenario. They're colliding elastically. It's mean their kinetic energy before and after should be same. So what they are asking, what the options are: sphere X rebound with a velocity greater than u, and sphere Y move off with a speed that is less than u. Okay, what you have to keep in mind: kinetic energy is a scalar quantity, so direction does not matter. If something move with a greater than u velocity, the same object, it's mean initially kinetic energy was less, because initial total kinetic energy, if I say kinetic energy is half mx u square, that is the total. So final it should be less than this, not more than this. So if you see the statement A, this kinetic energy is representing more than that value. Okay, direction does not matter, they both the kinetic energy of this x and this y will be added up, so it is much more than the initial. That cannot be the case. Okay. In B, sphere X rebound with a speed that is less than u. Okay, so the kinetic energy will be less, and sphere Y move off with a speed that is also less than u. Okay, both the speeds are less than u. It can be of any amount. So there's some can be less than the initial kinetic energy, So that can be a case. Okay, so it can be true. Sphere X rebound with speed u and sphere Y remains patient. If it's even rebounding with the same speed, so kinetic energy will remain conserved. That is not the case in the inelastic plane. Okay, if you see and why. Okay, so you have to keep in mind this thing. Okay, and in sphere X remain stationary and sphere Y move off with a speed that is less than u. Okay, so this is basically this is the elastic plane. Okay, so the kinetic energy should be the same. It will not be the less, it will not be the more. In that case, it is conserved. That is not the elastic plane case. Okay, so I guess I have mistakenly said opposite of it at the start. It is elastic plane. So kinetic energy at the start should be the same. So B is the right option. Why? Because some of the kinetic energy is of the X, that will be the less than the initial, and some is to the Y, that is also less than the initial. So there is some can be equals to this thing. Okay, so the B option is correct. In the next, a ball of mass is thrown towards a stationary vertical bat. The ball hits the bat with the horizontal velocity of this. A ball rebound and leave the bat with this much velocity. What is the change in momentum? Okay, so it's the ball is moving like this. Then after striking, it's moving back with a velocity of 15 meter per second. We know change in momentum is mv minus m2. Mass of the ball is basically zero point 0.1. You can take, if you take this positive, this will be taken as negative. It's the convention, you can take other way around as well. So it is 15 minus zero point 0.1 and then it will be minus 20. Okay, so this thing will give you 3.5 Newton second. This is option D. Okay, two satellites in deep space collide inelastically. What happened to the total kinetic energy and momentum will remain conserved for all the cases. Kinetic energy should not be the same, it should be the reduced. Okay, so it's option C. What is the reasonable estimate of momentum of a family car traveling at 25 km per hour? Okay, so you have to estimate. We know roughly the mass of the family car is 1000. If there are some passengers as well in the car, so you can take it as 1200 kg or something, right? We're just estimating, that is roughly nearly this thing. And the velocity is given, that is 25 kilometer per hour. You have to change, options are in meter per second, right? So you have to change this thing. 25 for kilo, you have to multiply with 1000. For hour to second, you have to divide it with, because it's the r is in the division, it is like this. That thing will give you, okay, that will be the velocity. So to find the momentum, momentum is mass into velocity. Mass is this is 25 into 1000 divided by 3600. So this whole scenario will give you answer around, let me calculate this thing. So we have 25 into 1200 into 1000 divided by 3600. So that will give you 333.33. And okay, so that can be equals to 10,000 or something. This is the estimate. Okay, the best estimate of this thing, right? Okay. The next question, a ball collided with a wall. Before the collision, the ball moved with a velocity of 8 to the right. After collision, it moved to the left. What is the change in velocity? So if this is 8, this is 3. If this is positive, this will be negative. So change is v minus u. Okay. So if you take v is minus 3 minus 8 is, this is 8. So this will be minus 11. Okay, meter per second, that is a change. And as it's finally moving to the left, so it will be the 11 to the left. Okay, Okay. So that's it for this video. In the next video, we will try to solve some more questions of 2024 and 2023 years. Okay. So see you in the next video. Thank you.